This is 6.1, Introduction to Polynomials. This is just an example of what a polynomial looks like. You don't need to write this equation down in your notebook. I just want you to look at two important pieces though. It's called the leading coefficient and the degree. The leading coefficient is the coefficient in front of the highest term. So that's this piece here. Again, you don't need to write this down, we'll practice it. And then the degree is the highest power in your polynomial. Another vocabulary word is standard form. We refer to it a lot in Chapter 2 or Chapter 5, so I'd say you don't need to write that down. Standard form is we want to make sure all of our terms are in descending order. What I would recommend that you write down is this chart. We're going to start to graph higher order polynomials. So this chart is focusing on the degree. So if I have a fifth degree polynomial, like x cubed, or x to the fifth, sorry, then the name of it is called a quintic polynomial. The shape is going to look like a snake or an S. The next polynomial is a fourth degree polynomial, like x to the fourth. The name of a polynomial of fourth degree is called a quartic function. The shape of it looks like a W or an M. A third degree polynomial would be like x cubed. We call those cubic functions. Their shape looks like a snake or an S. What probably looks familiar to you are the last two. If it's a second degree polynomial, x squared, which was all of Chapter 5, its name is called a quadratic, and its shape is a parabola or a U. And then earlier this year in September and early October, we focused on first degree polynomials, like y equals 3x plus 5. Its degree is 1. We call that a linear function. Its shape is a straight line. So go ahead and finish writing up that chart. Then polynomials have a certain number of terms. So go ahead and write down this next piece. If you have a single term in your polynomial, we call it a monomial. If you have two terms in your polynomial, then you have what we call a binomial. So think of this one as 3x plus 5. If you have a trinomial, that means you have three terms, something like this. X squared plus x minus 9. 4 or more terms doesn't have a fancy name. We just call it a polynomial of x terms. So if it was 5 terms in it, we'd say a polynomial of 5 terms. And here would be an example of a monomial. So here's what you might have to do in your homework. Classify a polynomial by its degree first, then the amount of terms. So this example, I just want you to look at. We're going to practice it on the next slide too. So don't write this black example down. We're giving you 3x to the fifth minus 2, and we want you to name that polynomial. So first we talk about the degree. The degree is fifth power. So if we go up to our chart, a fifth degree polynomial is called a quintic. So that's this name right here. And then we go next. How many terms does it have? It has a term here and a term there. So we go and look at how many terms it is. It's a binomial. So it is called a quintic binomial. We're going to practice this on the next slide. These are the graphs that I was talking about also. We're not going to have you graph these. These are just kind of a preview to what will be coming later. So the first one is a linear function. The second one was the quadratics from chapter 5. You're going to see more like the cubics, which are the snakes, the quartics, which are your W's or your M's, and then your quintics go back to snakes. So just kind of wanted to show you those. Don't write them down. All right, so let's practice this problem. Write in standard form, state the degree and the leading coefficient, and then classify it. So here's what we give you. The polynomial is 3x squared minus 2x to the fourth plus 4. And we want it to be first in standard form. That means in descending order. So we look at the terms. We have 3 terms. Our highest term is x to the fourth. So this term is going to go first. Then we go to the second term, which will be 3x squared, and then our constant. So now we have it in standard form. Negative 2x to the fourth plus 3x squared plus 4. Then we want to state the degree and the leading coefficient. So we look at the degree. The degree is a fourth power. And then the leading coefficient is what's in front of that highest term, which is negative 2. Now we need to classify it by its name. So to classify, we first classify it by its degree. It's a fourth degree polynomial. So the name for a fourth degree polynomial is called a quartic. Then the next thing to classify it is by how many terms it has. 1 term would be a monomial. 2 terms would be a binomial. 3 terms would be a trinomial. And this is what we have, is a trinomial. So the name of this polynomial is a quartic trinomial. The next example I don't want you to write down. We're just going to follow along. So you can go ahead and put your pencils down. So it's the same question again, but now we have more terms. So I want to put this in descending order. I look for the highest term. See if you can find the highest term. You should have gotten right here. So we know that that's the highest term, and then we put the rest in descending order. So the next highest term would be the 2x to the fourth, and then 8x cubed, and then 3x squared, and then 7x, and then 1. Be very careful. You might want to cross out and write each place so you don't miss any. So now it's in descending order. Now it asks us to state the degree. See if you can find the degree. And then the leading coefficient. So here is my degree, and then there is my leading coefficient. So my degree is 5. My leading coefficient is negative 6. Now let's go ahead and classify it. To classify it, we look at the degree. The degree is 5, so that is called a quintic. And then we look at how many terms it has. It has 1, 2, 3, 4, 5, 6. 6 terms. So this does not have a fancy name for it, so it's called a quintic polynomial with 6 terms. Let's go on to the next example. I would recommend that you write this example down. We want to evaluate this expression. So we give you a polynomial. It's a quadratic polynomial. It has 3 terms, and we want to evaluate it when x equals negative 2. So what that means is we substitute negative 2 in for x. So we have an x here and an x here. I highly recommend you throw parentheses in when you evaluate. So we're set to substitute in. So 2, now I'm going to remove the x and replace it with negative 2. Then plus 3, remove the x and replace it with negative 2. Now I reduce it. So I do my orders of operations. So I multiply negative 2 times negative 2, which is 2. Then after my exponents, I multiply. So 2 times 4 is 8. 3 times negative 2 is negative 6. And now I subtract 8 minus 6 is 2. And then 2 minus 5 is negative 3. We'll pick up on the next part.